welcome Mohammed Ikram to the stage.
Thank you very much. Welcome and good morning, everyone. How are you doing? Doing good? Okay. So today I will be talking about our work that we have done at Macquarie Uni Cybersecurity Hub with an Emirates degree student for about 6 to 9 months. On how can we use LLM and AI-based systems for prioritizing vulnerabilities. And I hope that some of you already know about what are vulnerabilities and why prioritization helps in tackling those vulnerabilities in the systems that we use and the system that we leverage most of our financial as well as businesses as well as many different applications out there. Um, Here is the outline of my talk. I would try to briefly introduce you little bit about the different framework that were used or they are being used in industry to prioritize vulnerabilities and to triage those vulnerabilities. And then I would talk about how can we leverage LLMs and how can we use these different techniques which are out there, for instance, like prompting techniques, the pre-training, the fine-tuning, and so on, and which among those different LLMs which are out there can help us the most. So I will talk about that in this talk, and I will try to present our methodology that how we automated vulnerability prioritization and how can we leverage LLMs to reduce the cost and make the prioritization much more um, effective and efficient. Okay, so a step back, why it is challenging to prioritize vulnerability. We all know that software and systems are developing at a very fast pace, and there are attackers and there are like different developers who may not be security aware, where they would try to use these third-party libraries and maybe components from from other parties in their system to speed up their development process and to meet the requirement from the ever growing and growing and fasting technologies and demands from the industry. Uh, so our thesis is software and system vulnerabilities, in short ones, appear faster than remediations, and attackers weaponize faster than defenders triage. And I think in today as well as tomorrow, some of the presenter would talk about that how LLMs and even these underground LLMs can be used to weaponize the different techniques and the different procedures by the attacker to attack the system that we use. Um, Last year, there was about 29,000 CVE reported with high security or severity risk in the major vulnerability databases, and it showed that more than 200% growth in critical high vulnerability over the past 5 years. And we are not sure that whether this is because of the skill level of the attackers or maybe the over reliance of developers on those third parties and copy the codes and um, these different method that they use to fastly develop their software, or this could be depending upon the LLMs that they use or the different system they use to find vulnerability and to enhance the vulnerability search. So we don't know exactly, but there are some statistics in our research that we found out that worthwhile looking at. And we found out that 60% plus vulnerability missing key metadata. This could be like, is this vulnerability appearing in the core um, component of a system or core services of a given enterprise, or this could be either on a service disk and so on. So those critical information or metadata is basically missing in major of the databases which reports or which uh, um, record or archive those different vulnerabilities. And we found out that 80% of the exploited vulnerabilities are exploited within 20 days of the first disclosure. So this is quite fast, and the exploitation, the time of exploitation is being reduced. And that's why we need to have, like, a system which can help us to faster detect those exploitations of the vulnerability, and then propose methods to either triage or track or handle those vulnerabilities in the system. We also know that security analysts face increasing volume of complexity. This basically result into a high cognitive loads on the very small security team that organization normally have to tackle vulnerabilities. And this is across the different sectors that we have analyzed and so on. And sometimes those cognitive load on security analysts result into inefficient handling of those vulnerabilities reported on the different organization. Now, traditional system have limitation. Sorry about that. Yeah. Well, the sound, the tone is very nice, so that's why I put it. Okay. So traditional scoring systems have limitations. Now, I hope that some of you already know about how vulnerabilities are prioritized depending upon their severity levels. There are different scoring systems which try to categorize those vulnerabilities, either high, severe, and things like that. They assign specific scores. This could be either categorical score, or this could be some numerical score that they assign to those vulnerabilities. And depending upon those categorization and the score they receive, normally security analysts try to, or like devise or revise their response in order to tackle those vulnerabilities. But they have inherently a limitation, because these categorization in the numbers does not tell you that where is this vulnerability lying. Is this in a critical system or a critical component of organization? So suppose that there is a vulnerability which is high severity, and if lies in the service disk of a given organization, should the security analyst prioritize this one compared to a medium severity level vulnerability which are founding in the customer database? Which one should they prioritize to tackle it? A general question for you as well. Normally, the security analyst should prioritize to protect the more core component of the system and try to prioritize vulnerability which lies in the core system and functionality of a given organization. But the scoring system will not tell you how to prioritize this one. So namely providing responses that are independent of organization context. So in a nutshell, those scoring systems in those different categorization that we traditionally use, that does not capture the context of the vulnerability. Where is this vulnerability lying? And so on. So in order to capture that context, there are different methods and framework that have been proposed. And our challenge and our question of the research is that how can vulnerability prioritization be automated in the context-aware manner? So this is something that we looked into with my MRIS degree students over the last couple of months, and we come up with a system to do this thing. Now, as I mentioned, there is this different categorization and scoring systems out there in order to prioritize or somehow rank those vulnerabilities. And some of them is that common vulnerability scoring system, CVSS. This is EPSS and SSVC. The most prominent one among these three, which capture the context of a given vulnerability, is the SSVC, which is proposed by America's Cyber Defense Agency. So they propose many different steps where a security analyst should take in order to either triage, track, or handle those vulnerabilities. And all those steps that that a given security analyst normally takes, there are manual. I would just go through one of their systems. If you go to and search SSVC calculator, you will find that in order if you receive a given alert for a vulnerability, how the security analysts take those decisions to either triage, track, or so on those different vulnerability. I will show you a demo as well, but before showing the demo, I would like to go through or walk through these different phases of handling vulnerabilities. So here is we have the SSVC calculator, and as you can see here, these eventually, like, this calculator would output a decision tree, which looks like here. And this decision tree normally based on the different decision that a security analyst should take on these different nodes. And for that, they should have like the background knowledge where to search the exploitation for the vulnerability, where to find the context of the vulnerability, and so on and so forth. So this was co-developed by CISA and CMU in 2019, and this framework is guiding vulnerability response actions, meaning that how security analysts should take an action depending upon an alert about security. This is a context-aware decision-making, meaning that they're not only using the scoring system and the availability of the um, exploitation, the analyst normally takes the context of that vulnerability lying in the organization. And there are four core decision points, which is exploitation. One decision point is that depending upon the alert about a given CVE or vulnerability, the analyst asks this question whether exploit is available for the vulnerability or not. And if the exploit is available, is this automatable? Can the attacker automate those exploits in order to attack the systems? And what would be the technical impact on this? Like how what sort of knowledge and what sort of methods are required for attacker to attack the systems, or vice versa, to counter those vulnerabilities being exploited? And mission and well-being, this is according to the organization. The last decision points that analyst normally takes is that if this vulnerability is exploited and if there are attack happening on the system, is my organization would be facing, let's suppose, breakdown, or the mission that we are providing, whether it would be breakdown and so on. Like, for instance, sometimes Sydney trains breakdowns because of the weather and things like that. If there are attacks in this, what would happen? If there is like critical infrastructure like dam, or maybe like nuclear power plant or power plants and so on, would they stop working and so on? So these are some of the decision points that they take. And this is, like when the exploitation is available here, you can see here, then these are the different questions, like, this is not automatable, POC available for that vulnerability. And here, this is active, meaning that exploitation is available out there and it is active, which can be used by attacker. And nowadays, we already know that building POC and automated task with LLMs is quite easy for most of the developer and attacker, and this could be really fast. And this is what I talk about, that the exploitation of the vulnerability, the time duration has been reduced to 21 days. So this is how, like, LLMs helps in order to reduce. Let's assume that we choose that the exploitation, the vulnerability is not exploitable, exploit is not available, and it's not automatable. Then the next thing is that whether this is automatable, yes and no, and things like that. And then if you proceed further to take this decision, then the mission, like criticality comes here, where the security analysts decide whether this would be severe or there would be some impact on the mission of the given organization if the vulnerability is exploitable and things and so on. And at the end, there are, like, these decision track, and I would show you in the demo these different decision here. So whether the analysts should track the vulnerability, or they should take an action in order to handle those vulnerability. This is the framework that they use. Let me go back. So stakeholder specific vulnerability, and if you can scroll down, you would see these calculator here, and this would be start decision. Okay, so this was, um, let's say, clear all. Then start decision. Let's say we have an attack which is alerted on a given SOC screen, and let's say the security analysts want to take an action, either to work on it, leave it alone, or maybe like track it. So the first thing that they ask that whether exploitation is available for that vulnerability or not. So here you can see that, let's suppose if none is available, is POC is available, or this is active. Suppose that attacker found the security analyst found out that there is exploit available for that vulnerability and it is automatable. Then the next step would be the technical impact. So the exploit gives the adversary total control over the systems. Let's say we take that this is yes, and then the mission critical. So this is if this attack happens in the customer service desk, then the mission may not be that much impacted for a given organization. So let's say here in AITD or Tape Meadow Bank, if there is a vulnerability in the customer disk, you can still register for a given course using your own phone, browse in there, and you can register yourself. So there is a way that you can control those. Let's say here we decide that this is essential, and this is public impact is minimal, material, or irreversible. Then depending upon those different decisions, you can see here it tells the analyst to act upon immediately on this vulnerability and tackle this one. And these are the different decision points that can be acted upon or used in decision making. Now, all of these points that what I mentioned here, these are manual, and the analyst has to make a decision. They have to search those databases. They have to know the context of those vulnerability and so on. So this is all manual task to do this thing. Now, the question that we ask, can we use LLM and can we use this system to automate some of these vulnerability? And there has been talk that, people have used LLMs to communicate with scammers, to communicate with different systems, and so on, and try to get those threat intelligence. And here we basically following a similar patterns in order to take this decision in there. Now, there has been a lot of work in the space where people have used machine learning algorithms in order to detect vulnerabilities. Some of them are like supervised learning, unsupervised, and reinforcement learning. They basically look into the modeling vulnerability and detecting and having the behavioral analysis of the vulnerability. There are some model like CVSS, BERT, which maps vulnerability to numbers, and there are different methods like GPT-based frameworks that try to build the context around those different vulnerability, but none of them had taken in ranking and prioritize vulnerabilities. So there is a limited use and organization context framework like SSVC. SSVC haven't been analyzed by all of these system or machine learning algorithm that I mentioned in the previous slide. So our contribution is that we evaluated the LLMs that are out there that we use um, for our work in our daily lives. How can we leverage those in order to automate those different techniques? And we use evaluated the different prompting techniques. We evaluated different fundamental LLMs in order to prioritize those vulnerability. And here is our work, like the schematic or maybe the bird eye view of our work that we did. So we have taken vulnerability from Walzu databases in order to have a ground truth of how our system compared to other system would work. So we use the Walzu vulnerability database as a ground truth. We come up with these different prompting techniques in the literature. So those who maybe like in machine learning algorithms, the people who are working there, they would know about zero shot, few shot, and so on, meaning that these are the different way of training machine or fine tuning the LLMs in order to rank or maybe like prioritize the vulnerability. We also those decision points that I mentioned, the 4 decision points, the exploitation, mission being, and so on, we also use those LLMs with the prompting techniques in order to find out those decision making. Um, like in a manner where, let's suppose, a security analyst would rather use LLMs for searching, let's suppose, is the exploit available for this vulnerability? Is it critical to my organization, and things like that? And it is what is the technical impact of this vulnerability, and so on. So we not only prioritize the vulnerability in large, but we also propose in a system where analysts can use the system in order to find out those decision points individually. We use these 5 different models like DeepSeek, Gemini, Cloud, ChatGPT, and so on. In order to benchmark those different LLMs with the prompting techniques and with the decision points. And then we have, like, extracted those decisions from LLMs, and then we analyze using these different matrices in order to compare and contrast these different prompting techniques, these different decision point prompting techniques, decision points evaluation, as well as the LLM's performance. And this is how we, work with. So we have had, these different vulnerabilities, and in this case, particularly, like, we use the example of this CVE, which is a window common log file, our driver evaluation privilege vulnerability. We use these different prompting technique here, like zero shot, chain of thoughts, memtex proxy. These are some of the prompting techniques that helps in order to better extract those information from LLMs. Like zero shot, meaning that LLMs is not trained with any prior vulnerability data. It's something like similar, like you just use the ChatGPT or Gemini as it is in order to evaluate them. And the next couple of experiments that what we did, we trained LLMs in a sense that, let's suppose, a given organization would be fine-tuning and training LLMs to do this prioritization task. And then we have these different mission well-being statement, like high, medium, and low. So the things that I showed you, that when depending upon the mission of the given organization, how can we basically find out whether this is critical or no? These are the decision find that we found out. It is because that this sample vulnerability database does not have this mission critical data points. So we generated those mission critical data points from LLMs by giving them scenarios, by giving them this, that we are, let's suppose, banking system, and this vulnerability happens. What could be the possible mission critical scenarios here? And let's suppose PowerPoint, let's suppose supermarket and center. So we give these different, like, scenarios for LLMs to generate those decisions. And these are the LLMs that we have analyzed, and these are the trials that we have made. And why we made this trial here is that sometimes these LLMs are non-deterministic. If you prompt LLMs with the same prompt, you would receive these different outputs. It's not deterministic. And in order to reach to a deterministic decision, there could be many trials that you can make, but depending upon the budget that you may have and the token that you would like to utilize there, we have had 3 trials there. And from this trial, we take the majority voting in order to find out that whether a given vulnerability need to be triage, and so on and so forth. So this is the technique that we use, and it is a technique used in many different research work as well in order to reach to a given conclusion. The data set, as I mentioned, we have like this Walzoo data set. We choose to take, these 384 vulnerabilities, for which we find out all the ground truth and metadata that we can use to analyze those data sets. And this data set is developed by people from in US, in Singapore. They collect the collection. So this is a high quality data that they have collected, and they use SSVC in order to prioritize those vulnerabilities. And here we have this evaluation one, which is we created and maintain So we maintained by CISA, which is automatable exploitation, technical impact, and so on. And we are they have like approximately 45,000 CVE ID, and we took the random sample of 384 different vulnerabilities and so on. We use these different LLMs at the time when we were doing the experiments. We have different costs for these tokens that we have used. Our decision was based on, since this was an Emirates degree student and as a senior lecturer at at university, we are limited with budget. So that's why we choose, to have a limited budget and utilize the money that is allocated for our research. So among this, here, cloud and DeepSeek, these were like, some of the expensive GPTs that we evaluated in our study. Um, so these are the prompting techniques, as I mentioned, and talk about that. One of the researcher that we base our methodology was Tony et al., who review who basically study the different prompting techniques, and there are these different prompting techniques that they have proposed to use, and we use these prompting techniques in order to evaluate our methods. Here is a very quick and very high-level statistic that we have figured out. We have extracted from our evaluation. So this is this figure shows the different LLMs like Cloud 3, ChatGPT 4, or Mini, DeepSeek, and Gemini Flash 1.1. So these are the the different decision points that I mentioned, like whether the technical impact, what is the technical impact, what is if this is automatable, and whether exploitation is available. If a security analyst use them as it is, what is the performance of these different LLMs? And we found out that among these 4 different LLMs that we used, Gemini result into a consistently high result compared to these different decision points. And as a disclaimer, we are not supported by Google, so we are not watching for Gemini. It's a basically pure research that we did, and this is what we found out about the Gemini. Which result into these different output. One, speculation could be is that Google has a vast majority of code base and so on, and it could be possible that Gemini is using that code base in their training, and that's why you have like this high result for Gemini and so on. Some of other key points, key finding that we did was that the prompting technique, which is a chain of thoughts, emerged the most effective techniques. Chain of thought is a methods where you basically walk through or guide LLMs to take a decision. And we found out that few shot with working example, meaning that let's suppose you give some example to LLMs and see them that how can LLM prioritize those vulnerability, also help us in better effectiveness in prioritizing the vulnerability. Simple techniques like zero shot and priming yielded weaker results, meaning that any analyst would use LLM as it is, just as we use LLMs for rewriting our emails or maybe like so on and so forth would not work in there. We also find out that ChatGPT have moderate and consistent response and excel with chain of thoughts, and DeepSeek with self-planning. This is another method for prompting aligned with its architecture. And we found out that cloud, which is expensive, is not that much effective in vulnerability prioritization and so on. And one of the points that we basically evaluated in our key takeaway is that modern prompting techniques and compatibility is crucial for optimal vulnerability analysis outcomes. So before you use LLMs for prioritizing vulnerability, you need to have like the best possible prompt and so on in order to prioritize the vulnerability. Our study has some limitation as well. We didn't evaluate it premium model that yielded stronger performance or the models that are security focused. We use, like the general available LLMs in our evaluation, and so on. And the data set that we have had, it's very small. One of the crucial point is that you won't find a ground truth database which has diverse setup vulnerability and so on. So our paper, okay, some of the points that I already talk about there. So LLMs show moderate efficiency. Gemini consistently outperform the model, and prompt examples significantly improve. LLMs cannot yield replace expert judgment. This is something that we already know, that there should be human in the loop in order to prioritize and rank vulnerabilities. It is effective as decision support tool rather than just replacing the human, but there is something that we can use to increase the efficiency of those attacks in there. Some references are here, and we have this paper available on archive. This paper would be presented next month in a workshop in US. My master degree student is Osama, who is outside the country. That's why he couldn't present. So he did a great job in working this whole work. The code is available on GitHub. So we use we use very nice tool to automate this whole evaluation. And if you are interested, you can check out this tool in order to use it in your research or in your work. Thank you very much for having me. Any question for me? Yes.
Hi, my name is Jeffrey. I'm from RCERT, the one people from Brisbane. Just out of curiosity, any other particular features that you've used to be able to train from the data? Was it just the vulnerability statement and the hope that Gemini would have known the context of the product, or was there any other features that you put in to be able to train and get those results? And also, leading to that, why do you think it did so badly with well-being, 0.43?
Oh, okay. Yeah. So good question. Like we use all the features that these different vulnerability databases would yield, like whatever feature that they provided to us, we use those features. Although there should be some work to extract those features and enrich those features with some more data so that you can improve the performance of LLMs. And so this is something that we left for future work. And we have this scenario that, let's say, what would an analyst do in order to prioritize vulnerability? So an analyst would go there, read some statement, and having a little bit of like context around that vulnerability. So we use that notion and perception that how analysts would think and work, and that's why we didn't went deeper into, and this could be further enhanced in the tool. Your second question is that what could be the impact on well-being? So with this tool, it would help the security analysts to better find, or efficiently find those answers that normally analysts would be searching and spending days and hours to find out those things. So that could help, not only the analyst, but also organization to better and faster and efficiently, like triage those vulnerabilities. I hope that I answered your question. Yeah, thank you. Yes, please. Yeah.
Patrick from Dan Secure. Just wondering, are you happy with the results? Like, how did it perform compared to what you expected and compared to what you thought experts would have accomplished? Did you do any, at least anecdotal analysis on that to get a feel for that?
Since this research work is just the initial phase, like a master degree student who does not have any research experience start and come up and do things in 6 months is really challenging to cover all the aspect. We did, evaluated the performance on some other aspect, overall categorization of the LLM, and we find out that LLMs can help us in hitting that 80% accuracy to prioritize vulnerabilities, meaning that it can reduce the workload um, um, on a security analyst who might be searching in and who might be prioritizing vulnerability and spending a lot of time. There are some work, and we are open to anyone who can test and try our system in their workload and tell us how effective this would be. So this is something that we are looking forward, and that's why I'm here to find out, like any help from industry to test and try our system.
Yeah, I mean, we'd be happy to help you with that. And I think that, an evaluation suite on this would be really helpful.
Yeah,
Voltu doesn't tell you what the right answers are, but there
yeah,
are some other evaluation suites around that can tell you,
yeah.
accurately what the right answer is, and you could test it against.
Exactly. Yeah, exactly. This was the data that was freely available, and we would happy, like to cooperate and work together. Yeah.
If there are no other questions, let's thank the speaker again.
Thank you.